Hello guys, welcome to the video. Today I'm going to be showing you how to make a digital dice with Arduino. And so I'm going to be showing you the circuit on how to make it, and then I'm going to be showing you the code. So without further ado, let's get this video. Now here is the circuit on how to make the project. And as you can see, we have a button and an 8-segment display, which will be displaying a number between 1 and 9. And so basically, if you want to know more about how this 8-segment display works, I have a link down in the description on how to use it. So basically, here we have pin 1, and it's connected to pin 10 on the 8-segment display, which is responsible for the G LED on the 8-segment display. And then pin 3 is connected to pin 9 on the 8-segment display, which is responsible to light up the F LED right here. Then pin 4 is connected to pin 7 on the 8-segment display, which is responsible to light up this LED right here, the A LED. And then pin 5 on the Arduino is connected to pin 6 on the 8-segment display, which is responsible to light up the B LED, which is right here on the 8-segment display. And then pin 6 is connected to pin 1 on the 8-segment display, and it's responsible for the E LED, which is right here. And then pin 7 on the Arduino is connected to pin 2 on the 8-segment display, and this is responsible to light up the B LED, which is right here. And then a pin 8 on the Arduino is connected to pin 4 on the 8-segment display, which is responsible to light up the C LED on the 8-segment display, which is right here. And then we're not going to connect anything to this pin because this pin is responsible for the DP LED, which is just the dot on the 8-segment display, and we're not going to be using that, so we're just not going to connect it up. And then you're going to connect one of the COM pins, either one you can connect to either side, and you can connect it to a G&D on the Arduino. And then we're going to move over to the button, and one side of the button is going to be connected to G&D, and the other side is going to be connected to pin 9. You don't need to put pull up or pull down resistor because we're going to activate the one in the Arduino. So no need to have a pull up, pull down resistor for the button. And so that's the circuit. So now I'm going to go ahead and show you the code. And so basically here is all the code. If you want to see this code or want to download it, go to the link in the description. There's a link to download the code. First, we put the pin that we have connected to our button into the variable button. And then we go ahead and we do byte digits. And then this digits array is going to be 7 slots wide. So basically 7 of these things are going to be inside of the first array. And then we have another number right here, which is responsible for these arrays right here. And they're going to be 7 slots. So there's 7 numbers in here. And there are 9 of these altogether. So that's why we have 9 right there. And it's 7 right here, which defines these just in here. So basically what this is basically, for example, this is the array for the number 1. So each LED, if it's 0, each number falls to an LED on the 8-segment display. Okay, and when it's 0, that means that specific LED that's in that order is going to be off or on. So basically if it's 0, then it's off. If it's 1, then it's on. So basically to light up 1 on the 8-segment display, we need to turn on the B LED and the C LED, and that will light up the both LEDs that make the 1 on the 8-segment display, and so on for all the other LEDs. And so basically all this is just the patterns of what each pattern of LEDs need to turn on based on the number we're trying to light up. Okay, and so then here's an array of all of the pins that we are using, and so that is what this is for. And then we have a couple variables here. We have random. This is going to be storing the random number that we get from our random function so that we can have a random value with our dice. Then we have button old and button new. This is going to be used for the toggle switch on when we press the button and the dice makes a random number. So basically, if these two numbers are different, then that basically means we have done something with the button. We have just pressed it or we just let it go. So we can detect that using these two variables to know if we have just recently pressed or let go of the button. So this is very useful, so we know when we should make a new random number to display on the 8-segment display. Then we have an unsigned long and last millis. This is going to be storing the last millis on right when we have let go of the LED, and so that we can pass that the bounce time. And so we have to wait a certain amount of time until we check and make sure that we should actually make a new random number to display on the 8-segment display, because we're trying to bypass that bounce issue. And so we wait a couple seconds to wait for that to pass, and then we start reading it again and see if this is actually a legit press And so then we have constant dt. This is just the delay time for how long we want to wait from the time we have let go of the button to when we should actually check and see if we're still not pressing the button to make sure that we have bypassed that to bounce this chute. So we're just waiting 50 milliseconds, which is hardly any time at all. So then we have a bool, and we have TF, which means true and false. And right now is false. So this basically tells us if we should go into this if statement right here, which I will explain later on. And so now I'm going to the void setup, and all we do is we set up all of our pins at once. So you may have not seen this before, but all this does is it goes through the seg pins, which are all the pins that we're using for our 8-segment display, and we're setting it all of them to outputs. So we're going through the whole entire array, each and every pin, and setting it up, because we are going to go through this for loop 7 times, and because it's going to continue coming through this loop, for loop until I is no longer less than 7, which means it has to be equal to 7 or greater than 7. And every single time we loop this for loop, I will be incremented, and at first I is equal to 0. That's why we make it int equal to 0. Okay, and so then we go ahead and we do pin mode button input pull up. So this is, we're just saying that the button pin 9 will be an input, but it also we need to activate the pull up resistor on this pin. That's what we're saying here. So then we have a random seed. This helps us with our random function. At first, the random function itself is not completely random. Yes, it's a list of random values, but the list is always the same, so you always have the same values or the same numbers all the time from the dice if you don't have this random seed. So basically, we're just making random seed, and it would just give us a list of random numbers. We could choose from whatever number we want. All we have to do is put a number into these parentheses, and it will give us a list based on that number. But the thing is that it's still not random if we just always put like 5 in here. It would always give us the random number list of 5. So how do we randomize this? Well, what we do is we do analog read 0, which is analog 0 basically. So reading from analog 0, which is basically connected to nothing. So this value that analog read will be getting us would be completely random. It could, because when we are reading from a pin that is connected to nothing, it's floating in the air. It's just all these numbers. It doesn't make any sense. So in theory, this will give us a random number right here for a random seed. Okay, so it will give us a random list of random numbers every single time we start with the Arduino. And then we just do serial.begin. I do this when I test and make the code, so it's not very important. Okay, so now we come into the void loop, and we go ahead and read the button. So we do digital read button, so that's pin 9. We're reading pin 9, and we're going to put that into button new, because that's the newest value from the button. And then we go ahead and we look at this if statement. If button new equals 1, which means that we are not pressing the button, because when we're not pressing the button, it's equal to 1. When we are pressing the button new should be equal to 0. So in this case, if button new is equal to 1 and button old is equal to 0, then come to this if statement. What this tells us is that currently we are not pressing the button, and previously we have came through this void loop and we were pressing the button, because button old is equal to 0, then come to this statement. So basically, we're going to come into this statement right when we let go of the button. And then we're going to set last millis equal to millis, basically getting the time of where millis was at when we let go of the button. So we know how long we need to wait until we come into this if statement right here. And then we just set TF equals to true, meaning that now all we're waiting for is that 50 milliseconds to pass, and then we can come into this if statement, because this is set to true. And once we come into here, TF will be set back to false, so that we don't come into this if statement multiple times. We have to press the button again to come back into this if statement. Now we're going to explain this if statement, and so we say millis minus last millis, and this will give us how long we have let go of the button. And if that value is greater than dt, then come into this if statement right here. So basically, when this statement becomes true, that means we have let go of the button 50 milliseconds ago. And then we say and button new is equal to 1, basically meaning if button new is still equal to 1, then come to this statement. So we need to make sure it's still equal to 1. We're not like pressing the button or something else like that. And then when you say and TF equals to true, meaning that we are allowed to come into this statement, then come in. Alright, so if all these are true, then we're going to come into this statement, and then we'll come into this statement and generate a random value right here between 0 and 9. So basically this is going to give us a random value between 0 and 8. And then we'll just put that random value into a random num. Alright, and then we can come here and do full int I equals 0. And then we're going to say we're going to continue looping this full loop until I is no longer less than 7. And every single time we loop this full loop, I will be incremented. So basically saying that we're going to be looping this full loop 7 times and then we are going to stop. So basically we do digital write seg pin. This is going to point to the specific pin we're talking about right now. So this is going to go through every single pin because as we go through this full loop, I will be incrementing. So we're going to be going step by step through every single pin number in this array and seeing if we should turn the LED on or not by giving value to the second slot, which is responsible if we're going to turn on or off. So basically this is going to point to the specific number that we are trying to light up. So let's say for example it's full, then it's going to be pointing to this array right here, and the for loop will be going through every single number here to see if the LEDs should be lit up. So it will then say, okay, we are trying to go after the number 4, so we're going to go ahead and go into the 5th array in the digits array, and then we're going to point to the specific number that is inside of the 4th array right here. And so we're just going to point to each and every one right here. That's what the I is for. It's for a specific number in here. And that's going to be slowly incrementing. So also we're going to go through every single one of these numbers through the array that is in the digits array, and that will display the number that we have gotten from the random function. And then we're going to say tf equals to false, since we have already lit up the 8-segment display of the random number that we have produced with the random function. Then we're going to come out of this statement, and we shouldn't come back in until we press the button again and let go of it. And then the last thing we do is we make button old equal to new, because we're about to come back up to this void loop and refresh button new. So we're going to make button old equal to button new, and then we're going to update button new and see if anything has changed with us pressing the button or like letting it go. And so basically that is the code. So now we can go ahead and see our project in action. Okay, so now here's the project, and so I'm going to go ahead and click this button, and it should generate a random number and display it on the 8-segment display. So I'm going to go ahead and click it, and as you see we got 6. I click it again and we got 1. Click again, we got 4. Click it again, we got 4 again, and then we have 8, and we can continue generating random numbers as we click it. And you may see that there's a little bit of blinking whenever on the 8-segment display when I click it, and that's just because of my button. There's some issues with my button with connections, but overall this is how the project works. And so yeah, if you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you all and have a great day. Bye.